Hello everyone. We're going to continue with some algebra today, although we're going to change up a little bit what we're doing. But at first we will review what we had been talking about. How do we expand out when we multiply these two binomials together? That's the main piece of algebra that we've been looking at, and adding a few other pieces in with that. So a reminder that as we do this, we're going to take each of these terms, the x and the plus 3 in our first bracket, and we're going to multiply that by both of the terms in the second bracket, which means we're going to multiply it with the x and the plus 5. Again, sometimes this is called our rainbow rule, because as we do this, we end up drawing all these lines in here that kind of look like a rainbow. We take the first term, the x, and we multiply it by both here, and we take the second term, the plus 3, and we multiply it by both terms here. As we do that, x times x will give us x squared. X times 5 will give us plus 5x. Positive 3 times x will give us plus 3x. And then lastly, positive 3 times positive 5 will give us 15. And looking through some of your work, some of you do need to be a bit careful with your integer work. How do we multiply integers together? In this case, we have all positives, so it's not that confusing. But when we start to throw in some negatives, I've noticed that some of you are struggling a little bit with your integer work, not necessarily your algebra, but just having some number sense problems. And if that's the case, then make sure that you are using a calculator to double check your arithmetic. Lastly here, we can then finish off by collecting our like terms. If I have plus 5x and plus 3x, we can add their coefficients together, which gives us plus 3 plus 5 plus 3, which is plus 8x plus 15. Our goal today, and for our next lesson as well, we're going to focus on this idea, is now that we have this, we want to now be able to work backwards. That is, what happens if I give you this trinomial? Can we figure out what are the two binomials that we multiplied together? So for example, if I gave you this trinomial, could you work backwards and could you figure out what those two trinomials are? So our first step in doing this is that we do know that we will be multiplying two binomials together, so these two bracketed expressions. So I'm going to start by putting two brackets. We also know that because this has an x squared at the start, that came from the fact that we multiplied these two x's together. So I know at the start of the brackets I must have an x and an x. So it looked like this here, and that's how we get this x squared, the same thing we have here. The next part I need to figure out, though, is how I figure out what are these numbers that go in the brackets. In this case, we had plus 3 and plus 5. And we have some clues. We have some clues as we look at this trinomial at the end, because that's the only piece of information that we're now given. So the first thing that I want to take a look at is this here. If I look at that middle term, I had a plus 8. So where did that come from? Well, if we backtrack, plus 8 came from the fact that we were adding the 5x and the 3x together. 5 plus 3 gave us 8. Does that give us a clue about our original question? Well, yes, because there is the 3 and the 5 right there. So those numbers show up right there. So what we know is that we had two numbers in these brackets, the 5 and the 3, and they added to this middle term. So in our example, that means that we are looking for two numbers that we know will add to, in this case, to 9. So I'm going to write that on the side and say I know that I have to have two numbers that will add to positive 9. The other clue that we have is this number that's at the end. In this case, we have 15. And if we backtrack and figure out, well, where did that 15 come from? Well, there it is. And how did we get that 15? So if we backtrack and look at all these lines that we drew, that 15 came from the fact that we multiplied the 3 and the 5 together. 3 times 5 gave us that 15. So we know that the two numbers that we are looking for are going to multiply to 15 in this example. So in our example, we are looking for two numbers that will multiply to 14. Now, some of you in this case may already be looking at this and say, I know the numbers that will work. For those of you who have really good really good number sense and number skills, you'll look at this and say, I know the numbers that will work. And that's fine. If you know them, go ahead, write them in the brackets. If you're not seeing them yet, what I'm going to suggest is this. I'm looking for two numbers that are going to satisfy both of these things. Two numbers that will multiply to 14, but they will also add to 9. What we typically do is we start with this multiplying piece and we look at, well, what pairs of numbers will multiply to 14? And if you're really stuck, if you're struggling with your times tables, we have a few options. One is just start with 1. Can I multiply 1 with something to get 14? And the answer is yes, 1 will always work. 1 and 14 will multiply to give us 14. And you can just go through your numbers. Next, I'll try 2. Does 2 work? 2 times what will give me 14? 2 times 7 gives us 14. Will 3 work? 3 times something give us 14? The answer is no. What about 4? Okay, 4 also will not work. What about 5? 5 won't work. What about 6? 6 won't work. What about 7? Well, that's where I know that I can stop because I already have 7 on this side here, so I don't have to keep going at that point. So I have two ways that I can multiply to 14. What I'm now looking for is, do I have a way that will then also add to 9? So if I look at these pairs of numbers, will either of these pairs add to give me 9? And if I add these two, we see that we would get 15. If I add these two, here's my answer. Those two will then also add to 9. So I can come over here and say, well, the two numbers that work then is x plus 2. And again, now we need to put that sign back in. So I have a positive 2 plus 2 and x plus 7. If some of you jumped ahead and were thinking the numbers in the other order, it's fine. You can put the numbers in whatever order you like. It would also be correct to write this as x plus 7 and x plus 2. The order that we write them in is not important. Lastly, I just want to show you this, and then we'll work through some examples together. If you're really having difficulty with your times tables in your homework, I'm going to include a multiplication table, and some students like to use this idea here. They'll go through the multiplication table and say, okay, I'm trying to multiply to 14. How do I multiply to 14? And you go through the rows. You can say, oh, there is 14. And here then are the two numbers that would multiply to give you 14. 2 times 7 gives us 14. Okay, this multiplication table will go up to 12 times 12. So a good number of the values that we're going to look at will be someplace in this table. So you could use that idea as well. Okay. So if I look at my next example here, again, these ones now just reiterating the steps. What are the thinking steps that we go through? So if I have this trinomial and I'm working backwards, okay, we call that factoring. I'm trying to figure out the factors that will work here. Factors are just what are the two things I would multiply together to make this expression. Again, to get a trinomial, I would have to have x and x at the start. That's automatic, so we can get this x squared. And I'm looking then for what are the two numbers to fill in. And our clues are these here. I have a plus 7 and a plus 12. So we will add to the first number. So I'm going to add to 7. And then we need to multiply to this number, so I need to multiply to positive 12. If you can see them right away, go ahead and write the numbers in immediately. If you can't see the numbers that will work, and this may change from question to question, maybe you saw these ones right away and now you're looking at this one and saying, well, how am I going to multiply to 12 and add to 7? Then you can start to write them out. And again, if I'm doing it, I just do this in order. 1 and 12 will work. What about 2? Yes, 2 and 6 will work. Some of you may have thought about that pair of numbers and saying, but those don't add to 7. That's right, because there is one more pair that will work as well. Don't forget, if we try the next one, 3 times 4 will also give us 12. And then we're trying to find, well, of these three pairs of numbers that will multiply to 12, which one will add to 7? And hopefully now that we've written them all out, we quickly see, hey, there's the pair that will work. So we come back over here and say, here are the pair of numbers that will work. So my two factors are x plus 3 and x plus 4. So really this whole process just turns into a bit of a number game. And again, for those of you who are really good with your integer skills, this will be very easy. For those of you who that's a little bit more of a struggle, this will be a little bit trickier, and you may have to do a little bit of writing here on the side to figure out those pairs of numbers that will work. If we look at this again, just to get that pattern, I set up these two binomials with x's at the beginning. Okay, I'm looking for two numbers then that will add to 11. And then they will multiply to 24. In this case, I have tried to pick some that are a little bit bigger, that maybe this is going to cause a little bit of confusion. So again, if we're stuck, I would start with 1 and 24 will work. 2 and 12 will work. 3 and 8 will work. 4 and 6 will work. And if you try 5, that won't work. This point I'm going to pull over that multiplication table just to say again, we can use this here. We could go through and figure out, well, where do we have 24? There it is once. So 12 and 2 work. Where else do we have 24? There it is again. 8 and 3 will multiply to 24. Where else? I have it here. So I have 4 times 6 will work. So you can use this multiplication table to try and search out that number and find out what pairs of numbers work if that's something that's difficult for you to do. As we do this then, I'm looking for, well, what one of these pairs will then add to 11. Okay, and hopefully again, as we write out all these pairs, we see there is the pair that will then also add to 11. Okay, first one adds to 25, doesn't work. This one adds to 14, doesn't work. This one adds to 10, doesn't work. Here's our pair of numbers that will do both things. It will add to 11 and it will also multiply to 24. So my answer here, x plus 3, x plus 8. And then we'll do one last one here together. So again, I set up these two brackets. How do we get our x squared? We put the x at the start of each of the brackets. I'm running out a little bit of a space here, so I'm just going to write this underneath. I'm going to say, okay, I'm looking to add to 11, and I want to multiply to positive 10. So if I do that, I'm looking at how do I multiply to 10. So 1 and 10 will work, and 2 and 5 will also work, and I'm looking for the pair that will add to 11. In this case, that's this pair here. I chose this last example because often students end up forgetting the fact that we can always take 1 and multiply it by the number itself to multiply to 10 or any of these numbers here. So often students forget about that first case, and when they're trying to do this in their head, they think of all these other pairs and they figure that this is not working. You may need to write it down as a reminder. Don't forget that 1 times the number will also work here as well. And there's our pair that works. Hope that helps. Okay, there's an assignment there for you to try. See what you can do. We are heading into the long weekend, so please try to get this done before the long weekend. Have a great long weekend. And then on Tuesday, we will start with something very similar to this. We're going to still be doing this factoring idea, but we're going to add in some negative numbers here as well and figure out how can we find those numbers in that case. Have a good day, guys.